Hey, lovely people, welcome to another video on circular measure. In today's lesson, we are going to tackle some difficult questions, and I've rated them as difficult based on their question number. You can see this question number 10. Question number 10, question number 11, question number 9 are normally challenging. So this is 2015 October November variant 1-3, and this is an IG paper. So let's read the question and see how to solve it. The diagram shows an isosceles triangle ABC. Okay. And we have been told that AC is 10 centimeters, AB and BC are 6, as we can see on the diagram. Then um, BX is an arc. BX is an arc of a circle with center C. So the center is C. Okay. And BY is also an arc of a circle with center A. So they have the same radii. Okay. So show that ABC is 1.97 radians. So how can we do that? Before you do that, please pause the video, attempt it yourself and see what you get. All right. I believe you tried it yourself. Now let's do it together and see what you get. Now here, if I want to find ABC, that's the angle at the top here, I can use the cosine rule. Okay, I can apply the cosine rule. As you can see, it's 2 marks. You're not going to do much. So 10 squared is equal to 6 squared plus 6 squared minus 2 6 squared cos of the angle. The angle is what? Angle ABC. So this will give me cos of angle ABC is equal to -7 on 18. Now I find the cos inverse of both sides. If I do so, cos inverse of both sides. If I do so, I'm getting 1.970 radians. Find the perimeter of the shaded region. Perimeter of the shaded region. First of all, in order for us to find the perimeter of this, we need to know the length of the arc. Right now, you know this side to be 1.97, right? So you can easily find the angle here. I can easily find the angle at this side. Okay, so angle, can I say that twice of angle BCX? Twice of angle BCX plus 1.97 is equal to the sum of angles in a triangle is what? 180 is equal to pi. So now let's make Let's make B as the subject. So I make angle BCX the subject. And if you divide, you should get 0.586 radians. Then let's come and look at the diagram carefully. From center, this is the center C, mind you. From center to circumference, this is a circle. So if the circle extend, this is the circumference. From center to circumference is the radius. So from center to circumference again, that's the length here. The length there to also be what? Radius. Let's forget about the angle here for now. So right now I have a sector. The angle in the sector is 0.586 radians. Now the length here from X to C is 6 centimeters. Okay, that means from this side to this side is 4. All right. Okay, very good. Now, so we know that that side is what, 6 centimeters. So the radius of the sector is 6. So what can we do? We can use that to find the length of the arc. That's bx. If you want to find the perimeter of the figure, it's basically the length of this arc plus the length of this arc, which is the same as the one here, plus the length here. Okay, so now let's find the length of the arc and see. So length of arc bx, your radius is 6, your angle is 0.586. So when you solve this, you are getting 3.516 centimeters. So twice of it will give us the length of um the two arcs. Then left with the length of xy. That's not difficult to find because right now you know that ax is 4, so this side will also be 4 because they have the same angles. The angle here too is 0.5586. The isosceles triangle. The radius too is the same. So if here is 4, here is 4. And so this side will be 2 centimeters. So if 4 plus 2 plus 4 is 10. So it's true. So the perimeter of the shaded region is given by twice the length of arc bx plus 2. So when I solve this, I'm getting 9.03 centimeters. Go back to the diagram and look at something carefully. Now look at this. Let me connect. Let me draw the height of my isosceles triangle. If I do so, you know that the height of isosceles triangle bisects the base. Did you know that it bisects because 90 degrees to the base? So this side will be 5. Okay. Then another thing is that I can find the height here. Let me call this side M. I can find the height of my triangle. Should I label it? I don't want to put in any new letter. I want to use what they have there. Okay, they didn't label this part. So here's 5. Here's 6. So I can easily find the length here. The length at this side, let me say is y. So y squared plus 5 squared is equal to 6 squared. Pythagoras theorem. So if you solve this one, you will get set 11. Okay, so let me come and put this in here. It's very important for finding the area. Okay, then I can also find the area. So I know when I know the height of the triangle. Okay, now if I know that, I can find the area of the whole triangle here. See, I can connect this side. I can connect this and that. This is the triangle I'm talking about. You can find the area of the whole triangle because you know that the base is 2 centimeters, then the height is said 11. So now let's find the area of triangle. The triangle is I can call it XBY. So area of triangle XBY. Area of triangle XBY. That's half times base times height. What is the base? The base is 2 and the height is said. The height is what? Said 11. So right now, I know for sure that the area of XBY is said 11. Okay, now the last part left. Look at the diagram. Let's come back to the diagram. So I have been able to find the area here. So if you look carefully, what is left? You can see that it's left with this side, which is actually a segment. A segment, you can see that's 2 segments of the same area. So I can find the area of the segment. Okay, so let's do that and see if I connect this. Let's connect this side and see. You can find the area of the segment. This one. Yes, you can. Do you remember the formula? So area of segment. Area of segment is given by half r squared into bracket theta minus sine theta. Now, since the segments are two, this one, I have to multiply my formula by two. Okay. So if I want to find the area of the two segments, area of the two segments, it will be twice of this. What is my R? My R is 6. My angle is 0.586. Alright, so this and this will cross out. When I solve this, I'm getting 1. I'm getting 1.19 cm squared. Okay. So right now I can find the area or the shaded region. So that should be 1.19 plus Z 11. Okay, so now let's calculate that and see what we get. So I'm getting 4.51 centimeter squared. So that's it for this question. Was it challenging? Let me know in the comment section. Sometimes you might think that the question is very easy until you take a pen and solve it. You never really see. So I'll encourage you to always solve the question before you watch my solution. So this is another question. This is 2020 winter variant 2.1. Okay, so we have two circles. The intersect at C and D. The line AC and BC are tangent. Okay, the centers are B and A. Okay, now the radius of the circle is 3 and 4. Find angle CAB. CAB. So the angle here, the angle here. Okay. Now, if they are tangent, the radius and this is a tangent, radius and tangent meet at what? 90 degrees. So I can use the tan ratio to find the angle at A. We can use tan of the angle CAB is equal to 4 on 3. So the tan inverse of this, so I'm getting my angle to be 0.927 rad. Okay. Find the perimeter of the whole shape. The perimeter of the whole shape. Now, there's not like a useless value. Now, the value that you have found, you are going to apply it in the subsequent questions. So we have 0.9927 here. Okay, so now I can find, you know, it's very important to connect the dots. We have heard that word before. That word is very, very important in this lesson. Just connect the letters, eh? Before I can do that, I have to be able to connect this. Why? Because I have to find the angle here so that I can find the length of the arc. So must I find the angle here so I can find the length of this arc. So I have to without that I can't find the angle. So if the angle here is 0.27, twice of it will be what? Let's find twice of it and see. I have 1.854. So that's the angle here. Here is radius meeting tangent. You know, if I extend this line, it will be a tangent, right? So we left with the angle at this side. So the angle at this side, let's see. So that will be pi, that's 90 plus 90, plus 1.854 should give me the angle at this side. So minus 2 pi, minus 2 pi. Do that, let's see what you get. Okay, I'm getting the angle there to be 1.288. So can you now find the angle here? When you find the angles, everything becomes simple for you. Is that not too big? Okay. So that is angle at a point sum up to 360 degrees. That is what? 2 pi. So it's 2 pi minus the angle here. 1 point. So I'm getting 4.995. Okay. 4.995. Can I find the angle here too? That will be 360 minus 1.854. 360 the same as 2 pi. So I'm getting 4.429. So right now I can easily find the length of arc what. Alright, so now we can go ahead and do our calculations. So the length of the arc here, this one, is going to be r theta, right? So the radius is 4. The angle is 4.995. So let's calculate and see what we get. I'm getting 19.98. Now let's come to this side. CD. So this is a small one, and that's the big one. So the small one is r times theta. Your theta is 4.429. I'm getting 13.287. In my final answer, I can approximate. Okay, so now let me just bring these guys down. So the perimeter is given by 13.3 plus 19 point. So let me add this and see. 13.287. Okay. 19.98. So I'm getting 33.3 corrected to three significant figures. Now the area of the whole shape. Okay, the area of the whole shape. Let's see what we will need. I can find the area of the sector here. This one. The area of this sector is given by half r squared theta. Okay. So now my r is what? 3. My angle is 4.429. I'll come back to this. Okay. Let's come for the big guy here. That's another sector. Can you see? So area of sector. I don't want to use CD because CD2 is here, and it's not the same as the major. This is a major sector, but there's also another sector here, which is a minor sector. So I don't want to use that word. I want to rather use big and small. So Half your radius is what? 4 squared. Your angle is 4.995. Let's cut and paste. Okay, let's go now and see. Now the last part. Area of this. This is a kite, can you see? Because this and this side are equal in length. This and this side are also equal in length. So it's actually a kite. Well, but I can find the area of this triangle and multiply it by 2. This one, and multiply by 2. So area of triangle. The triangle is what? BEC. It's a right angle triangle, so I can use half base times height. My base is 4. No, my base is 3. And my height is 4. So this should give me what? 6. So the area of the kite is twice of this, the area of the right angle triangle. So it is 12. So the area of the shaded region is going to be, I didn't find a value here. Let me do that quickly. $19.9, 39.96 plus 12. So 12 plus 39.96 plus 19.9. So now let's calculate this and see what you get. So I'm getting 71.9 centimeters squared. Alright, so they have to end here, but before I go, don't forget to hit the notification button for more updates. But don't forget to also share the link with your friends. You have been enjoying the video and you're not sharing the link. Come on, share the link. Well, I'll see you in the next one. Bye.